In this lecture, we're going to look at how to rationalize complex numbers. To do this, we're going to understand the meaning of rationalizing complex numbers. We're going to understand the conjugates and how we can apply the conjugates in rationalizing complex numbers. Rationalizing complex numbers it simply means removing the complex number from the denominator of a fraction. And you only rationalize when you have a complex number in the fraction of an expression. So let's see, which of these do you think we need to rationalize? 4i minus 2, the denominator is 1. I don't care about rationalizing that. Now, 9i minus 7 over 4, the denominator is 4, so I shouldn't have to rationalize this. What about this? We examine the denominator here, we have a complex number, we need to rationalize this. And then we look at this over here and we have a complex number, we need to rationalize this. Now we're going to understand conjugates. This is a very interesting concept because we need to find a number that when we multiply by the existing expression, or rather we need to find an expression that when we multiply by the existing expression somehow gets rid of the presence of the complex number. And the easiest way to do it is to rewrite the components of the complex number but change the sign on the imaginary portion. It's important to remember this as we show how we can get the conjugate. We have a plus b, a minus b. This is going to give us a squared minus b squared. Now we have 5 minus 3i. So what we're going to do is we're going to have 5 and then we have 3i. Look at the sign in front of the imaginary term is minus, so I'm going to replace this with plus. What about this case? Minus 4 plus 7i, we have minus 4 and then we have our 7i, we just change the sign, we use the opposite sign. Now let's apply what we've learned about conjugates to rationalizing complex numbers. The first thing we're going to do is identify the conjugate of the denominator here, and then we multiply the numerator and denominator by that conjugate. So let's look at the conjugate. We have our 1 and we have 2i. So I'm just going to switch this. So we multiply numerator and denominator by 1 minus 2i so that we do not change the expression in any way, because 1 minus 2i divided by 1 minus 2i is always going to give us 1. So now let's simplify this. This is going to be 3 multiplied by 1 minus 2i divided by 1 plus 2i multiplied by 1 minus 2i. So we have 3 times 1 is 3. 3 times negative 2i is minus 6i. And then we have 1 squared minus 2i squared. So this is going to give us 3 minus 6i divided by 1 minus 4i squared, which is 3 minus 6i divided by 1 minus 4 multiplied by negative 1, which is 3 minus 6i divided by 1 plus 4, which is equal to 3 minus 6i divided by 5. Now, you can leave it this way, or if you want to be creative, you can go ahead and say this is 3, this is 1 minus 2i over 5. Either way, it should be fine. Now let's look at this. our conjugate is going to be, we have 3 and we have 2i. We change the sign in front of the imaginary, so it's plus. So we now have 4i over 3 minus 2i. We multiply by 3 plus 2i, and then 3 plus 2i. So this is going to give us 4i, 3 plus 2i, divided by 3 minus 2i, 3 plus 2i. So this is going to give us 12i plus 8i squared divided by 3 squared minus 2i squared, which is 12 plus 8 multiplied by -1 divided by 9 minus 4i squared, which is 12 minus 8 over 9 minus 4 times minus 1, which is 12 minus 8 over 9 plus 4, which is 4 over 13. So that is how you rationalize this complex number. Okay, let's try this one here. What's our conjugate? Think of it as this. We have a 5, we have a 6i. Whatever the sign in front of the imaginary portion, we're going to change. So we have a plus here. So we have 4i minus 7 over 5 minus 6i multiplied by 5 plus 6i over 5 plus 6i. So this is going to give us 4i minus 7, 5 plus 6i divided by 5 minus 6i, 5 plus 6i. So now we're going to FOIL this. So 4i times 5 is 20i. 4i multiplied by 6i is going to give us 24i squared. Minus 7 times 5 minus 35, and then minus 7 times 6i is minus 42i. Then we divide by 5 squared minus 6i squared. So let's group common terms so we can simplify. So it's 20i minus 42i plus 24 multiplied by -1 minus 35 over 25 minus 36i squared. So this is -22i minus 24 minus 35 over 25 plus 36. So this is going to be minus 22i minus 59 divided by 61. So that is the rationalized version of that complex expression. And finally, we look at this example. Our conjugate is going to be, we have 2i and 7. Okay, we plus right here. We're going to change this sign to negative. So this is going to be 6i minus 3 over 2i plus 7, and we're going to multiply by -2i plus 7 divided by -2i plus 7. So this is going to be, so this is going to give us 6i minus 3 and then negative 2i plus 7 divided by 2i plus 7, negative 2i plus 7. So let's just factor the whole thing. We're going to FOIL this whole thing here. So negative 12i squared, and then we have 6i plus 42i plus 6i squared minus 21 divided by negative 4i squared plus 14i minus 14i plus 49. So now we have negative 12i squared is going to give us 12 plus 42i minus 6 minus 21 divided by 4 plus 49. Here's how we get to 4 plus 49. I squared is going to make this positive, and then this crosses out. So we have 12 minus 6, which is 6, minus 21. We have minus 15 plus 42i divided by 53. So this is what you do with rationalizing complex numbers. Key thing to know before determining whether you should rationalize is look at the denominator. If it has a complex or an imaginary number in it, you have to rationalize. If it does not, then you don't need to rationalize.